your last lesson for the week until you guys need to start preparing for your skills quiz. So now that you guys have practiced identifying slopes and intercepts, plotting lines from either their equations or from tables, and really looking at what those intercepts and slopes will do to this function, now we're just going to go through this list. We're not graphing anything today. We're just going to identify which one of these is going to create a line or which ones will not create a line. So, in fancy terms, we are identifying the linear functions from this list. So all we need to do is go through them and say either yes or no. Yes, they'll create a line, or no, they will not. So for the first one, what we're looking for is first, is it in slope-intercept form? For this one, the answer is yes, right? We have y equals a slope times x plus a number. So that one's really easy. It's in slope-intercept. I can identify the slope. I can identify the intercept. So this one is a yes. Okay, so we can say yes. This is going to form a line. This is a linear equation. Let's look at number 2. We're going to say we're looking at an equation. So is this in slope-intercept form? Do we have y equals mx plus b? So I have y equals a slope times a number and then an intercept. The slope is a fraction, but that's fine. It's still a number. Times x minus 1. That's definitely in slope-intercept form, so that is another yes. If you guys were getting curious, or if there's one you're not sure about, remember you can always go on to desmos.com and plug these in, and you'll see if they are lines or not just by looking at their graph. So let's look at our next one. Again, we're looking for slope-intercept form. So y equals a number times x. There's nothing here, but remember, that just means it's plus 0. So we have y equals mx plus b. Another yes. This is going to form a line. Number 4, we are looking at y equals something. Remember, if there's nothing there, that's okay. It's a 1, right? So it looks like m times something plus another number. Now, this right here is an issue. X squared. That is not y equals mx plus b. That's y equals something times x squared plus b. This is not linear. This is what's going to create a parabola. So you guys don't need to know this, but if you're curious, this actually looks like this. It's called a parabola. It is a quadratic function, not a linear function. Easy way for you guys to recognize that it's not linear is you can look at this and be like, we don't know how to do that. She didn't teach us that. It's probably because it's not linear. So the x needs to be to the first power in order for this thing to create a line. So notice all of these, x to the first, x to the first, x to the first. Every time you have x to the first power, it's linear. This is called quadratic. It is not linear. X is being raised to the second power. So we just say no. All right, number 5, x plus y equals 2. It does not look like it's in slope-intercept form, so you might initially say, nope, it's not y equals mx plus b. This is not linear. But the next thing you need to consider is, could you put it into slope-intercept? That one I couldn't because I had a second power, but this one I probably can. We can take that x and we can move it to the other side of the equation using inverse operations. So y could be by itself, and this becomes negative x plus 2. Now that looks like it's in slope-intercept form. I have y equals my slope, right, times x plus b. So this is actually a yes. We just had to do a little bit of work to get there. If you've got x to the first power like that, even if it doesn't look like it's in slope-intercept, do a little bit of maneuvering. See if you can figure it out. If you have x to some power other than 1, though, it's not going to happen. All right, number 6. We have y equals a number divided by x plus 3. So you might think, well, maybe I can move some stuff around like I did before, but in this one, it's not going to work out. So you might not remember this from our exponent rules, but when you have an x on the bottom, if you wanted to move that to the top, This actually is x to the -1. Again, that's from your exponent rules in Unit 3. Now, you have x raised to something other than a +1 power, right? These were all x to the first. This is not going to work. Your x has to be raised to the first power. You can't have any funky exponents going on. That is not going to be linear. Definitely not. That's called an inverse operation. You can plug that into Desmos if you're curious and see what it looks like, but it's definitely not a line. So we're going to be like, nope, not a line. It looks funky. We don't know how to do that. It's not in slope-intercept. Number 7, same thing. X to the 3rd power equals y plus 3. If that had been x to the 1st power, I could manipulate that. I can move it around and get it into slope-intercept. But as soon as you see that exponent and it's not a 1, that's a no. There's nothing we can do about that. We only want x to the 1st power. All right, let's look at number 8. I have 2 plus y equals 4x. So the y isn't by itself, but good news is x is to the 1st power, so I can manipulate this. If I want y alone, I've got to get rid of the 2. So I'm going to take that 2, and I'm going to move it to the other side. We're just going to subtract it. These cancel. I have y equals 4x minus 2. Now this thing looks pretty good. I've got y equals my number times x minus 2. Slope of 4, y-intercept of -2, x is to the 1st power. Everything looks great. That's a yes. All right, my next one is already graphed for me. So I'm just looking at that, and I need to determine if that has a constant rate of change. Is that a line? I'm going to say no. Notice it's not changing that much. It's increasing a little bit, but not much, and then it starts increasing a lot. So its rate of change went from a really low slope to a big slope. So it creates a curve and not a line. It is not a constant rate of change. So we're just going to say no, not a line. Number 10, on the other hand, this is a straight line. It's got a constant rate of change. If I count it, it's going like up 1 over 1, up 1 over 1, up 1 over 1, so it's constant. Nice straight line, constant rate of change, everything's looking good. That's a yes. That is a linear function. All right, the last two are in the form of tables. So we can't go by, does it have x to the 1st power? Could I put it into slope-intercept? Does it make a straight line? So the next thing we can look for when it's in a table, you could plot it if you really wanted to and just identify if it's a straight line. Or remember that it needs to be a constant rate of change. So let's look at the rate of change from each one of these points. So remember, rate of change is change in y over change in x. Let's find the change in the y value. This is going up by 6, while the x goes up by 1. So my slope is 6 over 1. Now let's see if it's constant. Here, from 9 to 27, what is that increasing by? I can't do math that fast. 18? Okay. So it goes up by 18, and this goes up by 1. So now my slope is 18 over 1. This is not a constant rate of change. If it were constant, it would be plus 6, plus 6, plus 6, as this goes up by 1. So this does not have a constant rate of change. It has a low rate of change and then a big one. That's a no. That's not going to make a line. If you don't feel confident doing it that way, just plot your points, see what it looks like, see if it makes a line or not. All right, my final one, we're going to do the same thing. We're going to check the change in y and the change in x, and we're going to see if it's constant. So 4 to 6, it went up by 2. This went up by 1. So between those 2 points, there's a slope of 2 over 1. Let's see if it's the same slope for the next set of points. 6 to 8 goes up by 2. 2 to 3 goes up by 1. So this is a slope of 2 over 1. We have a constant rate of change. It's moving the same way throughout the entire thing. So this is a yes. If you're not confident, you could plug it into, actually you could just plot them on a graph and see what happens. All right, so all we did is we went through a list of things. We went through some equations, we looked at some graphs and some tables, and you're just saying yes or no. Do you think they're gonna make a line or not? Use any kind of technology you need to help you out if you're stuck. And that was tricky. All right, these are the ones you guys are gonna try on your own, and I want you to do the same thing. I want you to look at each equation, table, or graph and ask yourself, could this be put into y equals mx plus b with an x having an exponent of 1? Does the graph form a line? And is there a constant rate of change? So you're gonna go through and you're just gonna say yes or no. So at this point, you can hit pause, do them on your own, and hit play when you're ready for the answers.